Hello. I'm going to attempt to show you how to do this note sheet. I hope this is working. Okay, I think it is. Good. All right. So anyway, the first question says, refer to the box below, identify the sets of points as collinear, coplanar, or three-dimensional. Okay, there we go. Okay, so first one says B, C, and H. Look, B, C, and H are all on the same line together. Therefore, they are collinear. So I'm going to write collinear down. Okay, the next one, it says, wow, sorry about that I. Collinear. Oh, that's as good as I can do. Next one, it says A, B, C, and E. A, B, and C are all on the top of the box. However, E is down at the bottom. Therefore, those 4 points are three-dimensional. Okay? Part C, it says B, C, F, and G. B, C, and F are all on the back of the box, but G is on the front. Looks like those are 3D. Now we have A, B, H, and J. Those 4 points are all on the top of the box. That means they are on the same plane together, which makes them coplanar. Part E says C, F, and K. Look, they're all on that line together right there. So they're collinear. Part F says B, C, E, and G. B and C are on the top of the box, but G and E are on the bottom. So that would make them 3D. Part G says A and K. They're not on the same line together, and they are not on the same plane together either. 3D it is. And part H asks for A, C, G, and K. Well, those 4 points are not on the same line, and they're not on the same plane either, so looks like they're 3D also. That concludes our warm-up. Time to start the meat and potatoes of the lesson. Example 1 says, find the intersection of the following lines. We're going to use what's called elimination to accomplish this goal. Notice that 4 is a multiple of 2. I'm looking at the coefficients of the x, 2 and 4. And 4 is a multiple of 2. So if I want to get the x's to cancel, what I'm going to do is actually multiply the top by the number that will, when I distribute, that will cause this to go to -4, which will cancel out with the +4. So I'm going to distribute this, oops, excuse me. I'm going to distribute this, what's that? I don't want that. Sorry, I'm learning how to do this. So I'm going to actually, oops, oh my gosh. I'm going to distribute this -2 to all parts of the equation. So that would give me -4x minus, because it's a negative times a positive, minus 6y equals -8. And we're going to leave the bottom equation just as it is. 4x minus 4y equals -12. If I combine equations now, the x's will cancel. Notice their coefficients are opposite, equal and opposite. That means they're going to cancel. -6y, take away 4 more y's, that's -10y equals -8, take away 12 more, that's -20. Divide both sides by -10, and it looks like y equals 2. How do I figure out x? Well, I'll tell you how we're going to figure out x. We got to plug in y in where the y goes. So I'm just going to use, I'll use the bottom equation, I suppose. We get 4x minus 4 times 2 is equal to -12. Again, that's because y equals 2, and I'm substituting in for where it is in the bottom equation. So 4x minus 8 equals negative 12. If I add 8 to both sides, I'm going to get 4x equals negative 4. Divide by 4, and it looks to me like x is going to equal negative 1. So our final answer is negative 1, 2. There you have it. Moving right along. Next one says, find the intersection of the following lines. Again, we're going to use elimination. But unlike in the last one where one of the coefficients was actually a multiple of the coefficient in the other equation, we don't have any that are multiples here, which means we're actually going to have to modify both equations by, sorry, these are supposed to be parentheses. This is supposed to be parentheses. By multiplying both equations to get coefficients that will cancel. We can either do the x's or the y's. In the last problem, we did the x's just because it was easiest. In this one, again, you could do either one, but I'm thinking that, I guess we'll just stay consistent and do the x's. So what's a number that both 6 and 4 go into? 24 is the one I'm thinking of, but actually, you could also do 12. 12 goes in, both of them go into 12. So how do I make the negative 6x into negative 12? Multiply the top equation by 2. How do I change 4x into positive 12x? Multiply the bottom equation by 3. So the modified equations will be negative 12x plus 2y. Oh, excuse me, not 2y. Remember, I need to multiply or distribute that too. It will actually be 4y equals 0. And on the bottom, we have 12x plus 15y equals, 3 times 19. Let's see, 38 plus 19 would be 57. 57. Okay. Notice the x's canceled just as we had planned, which gives us 4y plus 15y. That's 19y equals 57. Y equals 3. Divide both sides by 19. Okay, so y equals 3. That's good. That's halfway there. Now we just have to substitute the y into any of the equations to figure out what x is. I'm going to use the top equation. So we got negative 6x plus 2 times 3 equals 0. 2 times 3 is 6. Negative 6x plus 6 equals 0. That's where we're at right now. Just doing 2 times 3 there. Subtract 6 from both sides. You're going to get, I'm going to move down a little bit. You're going to get negative 6x equals negative 6. Oh, well, I happen to know x has to be 1, but if you don't believe me, you can divide both sides by negative 6 and find it out for yourself. So that means x equals 1, y equals 3. There's our final answer. Okay, moving along again. So show that both of those points, 4, 0, and 1, 2, satisfy both equations of the system below. This is as easy as just plugging the numbers into the equations. So let's check the top one. We're going to have 2 times 4 plus 3 times 0 equals 8. Let's just make sure that works for the first point. I'm plugging 4 and 0 into x and y. 2 times 4 is 8. 3 times 0 is 0. Oh my gosh, it works. Let's test the next point into the top equation. So it'll be 2 times 1 plus 3 times 2 equals 8. That's 2 plus 6 equals 8. Yep, that is true. Okay, let's try the bottom equation now. 4 times 4 plus 6 times 0 equals 16. That's 16 plus 0 equals 16. Yep, that works. And let's try the last point in the last equation. That would be 4 times 1 plus 6 times 2 equals 16. That's 4 plus 12 equals 16. Yep, that works too. Now, why is this significant? Well, it's because if you think about it, if you have two lines on a graph, they should only ever be able to intersect at one point, right? No matter how you draw the two lines, here's my graph, even if it's like really close to the same line, it should still only be one point that they intersect at. So how is it that we have two equations that intersect?
I can learn to understand you much better if I can get familiar with the way you talk. I need your permission to help.
Anyway, the answer is these lines right here are actually the same line. They're right on top of each other. If you were to graph these lines, it's going to be a situation something like this, where you have one line going like this, and the next line also going just like that right on top of it. So really, these two lines have infinitely many intersection points. Not just those two, not just these two, but actually infinitely many. All right, moving on. Oh, that rectangle's not going to go away, are you? Well, sorry, you're going to have to live with it because I don't know how to work this darn thing. Anyway, okay. It says, given the system of equations, find all the points in which the corresponding lines intersect. See how y equals this right here? I'm going to take that and plug it in for y right there. Just substitute the whole thing in for y. So you're going to get x plus 2 times 3x minus 5 equals 5. Distribute the 2, you get x plus 6x minus 10 equals 5. X plus 6x is 7x minus 10 equals 5. Add 10 to both sides. You're going to get 7x equals 15. And unfortunately, we're going to get a kind of a weird fraction here, but it is what it is. So x equals 15 over 7. Now that I know what x is, let's substitute in right there and solve for y. So we have y equals 3 times 15 over 7. Pretty sure, yep, 15 over 7 minus 5. 3 times 15 over 7, hopefully you know how to multiply fractions. That comes out to 45 over 7. You just multiply right to the top in case you forgot that. And minus 5. But I'm going to write 5 a little different. Hopefully you'll agree with me when I say that 35 divided by 7 equals 5. So those are actually equal. Minus 5 is the same thing as minus 35 over 7. 45 over 7 minus 35 over 7 is 10 over 7. And so our final answer is a weird fraction, but it is what it is. It's 15 over 7, comma 10 over 7. There you go. There you have it. Okay. Oh, I zoomed in. I wonder why I did that. Let me try to go normal again. Okay. And this is the final example, thank goodness. In the coordinate plane are the following lines parallel? Well, let's try and do what we normally do on this. Let's assume there's an intersection point. At the point where these two lines intersect, they must have the same y value. And therefore, I can take what y equals in one equation and substitute it in to the y in the second equation, which gives us 2x plus 3 equals 2x plus 5. If I subtract 2x from both sides, you end up getting 3 equals 5. This is false. This is false. So that must mean that our original assumption, oops, what am I doing? That must mean that our original assumption was wrong about them intersecting, which means they are parallel. So the answer to the question is yes, they are parallel. How could you have told that right away? Just look at their slopes. They have the same slope of 2. Since they have the same slope, you know that both lines are going to be going up at the same rate, and therefore they are parallel. All right.